Welcome to the class. Today topic is AC motors for the third to fifth and TS SBTET students. So coming to the topic, first what is the contents are there? So let's check it. The first chapter we having the synchronous motor, and second chapter starters and applications of synchronous motors. We'll go to the first chapter first, and here the synchronous motor. So what are the contents is there? So first we'll in detail we'll talk about the total unit. We can see. So first here we're having the rotating magnetic field, another one synchronous speed, and parts of the synchronous motor, and the excitation of rotor. Okay, so these are the first we are discussing today. So first we'll talk about the what is the magnetic field, rotating magnetic, that is a RMF. So which are talk about the RMF, what we are know, and another is a synchronous speed. So we know about the different speed. We'll indicate with the NS, that is synchronous speed, and why we are naming. Okay, so we are naming the motor with the synchronous. Okay, so why we are naming the synchronous motor, and what are the parts of the synchronous? Okay, so there are different types of the uh, parts, and depending upon the rotor. So we'll having the different configurations of the rotor, so that we'll talk about, and excitation. Okay, so why we need the excitation? Okay, so to run the synchronous speed we require the excitation. Okay, so based upon the excitation, so we'll having the this, so phasor diagrams, effect of load, and so we'll talk about the this V curve. Okay, so we and inverted V curves, so this also comes under excitation. So based upon excitation, so this will V curve and inverted V curve comes. And first we'll talk about the, so what is the rotating magnetic field, then we'll go to the in detail. So first we'll start with the motor. Okay, so as we know that, so motor is a device which converts electrical energy to the mechanical energy. So in case of generator, so generator what will do? So generator mechanical energy to the electrical energy. And here we'll talk about they depend upon the supply. So we're having the AC motors, and so AC machines, and DC machines. Okay, so in the AC we'll having the single phase, three phase machines. In the DC we'll having the only, so positive and negative. So we'll having the only the machines, so that will having depend upon the generators and the motor. Okay, so here we'll having the first we'll talk about the AC motor. So this topic is a synchronous motor topic. So first what will talk about the AC motors. Okay, so first AC
Okay.
motors can AC motor is a motor which operates the AC supply, as we know. So if it is a DC supply applied, then it's called as the DC motor. Okay, so that we'll already used to read in the previous semesters. So first here the AC supply. So here AC supplies are we having the two types. Okay, so previously having the single phase, two phase, and three phase. Now we were only using the single phase and three phase. Okay, so single phase and three phase. So depending upon supply, the motors are classified into single phase motors and three phase motors. Another also type of motor is the special purpose motors. So that is another classifications we can other. So just depend upon the supply, that's single phase and three phase motors. So here classification if you see according to the principle of operations, and another thing is that we can say that according to the speed. Okay, that is the synchronous speed and asynchronous speed, and operating principles that we will also don't know, and type of according. Okay, so and another is the structural features. So these are the classification that will be. So the questions also may comes for us 1 mark questions may appear in the semester end examination as well as the mid examination. Okay, so here the classification and according to the location. Okay, so because we can see here the single phase and three phase induction motors in the general which are using the domestic purpose. So suppose if we case the location. Okay, so here in our homes. Okay, so in our home we'll having this sum, Okay, so in the sump, to lift the water from the sump to tank, so we'll placing the, that is the location. Okay, so the outdoor. So but in case of agriculture, so we'll using the well. Okay, so in the well, here the motor we placed. Okay, another. And coming to the agriculture, it's a bore well. So if it is a normal well, so now electrical bore well if we consider, so in the bore well, that will be below the ground. Okay, and that motor is filled placed in the under. Okay, so that's right, the this is the classification according to the location. Okay, and another we'll talk about here. First we'll talk about the working principle. Okay, so here that we can say that these are the depending upon the speed. Okay, so the motors are working principle, so there is a synchronous motors and asynchronous mode. Okay, so first we'll talk about the synchronous and what is asynchronous. Okay, so first synchronous means the machines which rotate at the synchronous speed. Okay, the motors which will rotate, that is the AC motors which rotate at the speed of the synchronous mode speed, then it's called as the synchronous motors. Okay, whatever the speed is there, suppose if the speed of the synchronous motor, so as we know that ns is equal to 120 f by p. Okay, so here if you consider the 50 and poles are 4, then we'll get the some value. Okay, so that is the ns value we'll get. So if the whatever the ns value will get, so based upon the motor also run at the speed. Okay, so then that type of motor is called as the synchronous mode. Okay, so let's consider the that example is the one is example is the one alternate. Okay, so alternate is one example as a mode. Okay, so alternate is a generator, so that's why sometimes alternators also synchronous generators also called. Okay, so the speed also will run at the synchronous speed, that's why alternators are synchronous generators. Okay, and another we can say that another classification that is a asynchronous mode, means the motors which does not run at the synchronous speed. Okay,
Yeah.
that type of motors are called asynchronous motors. These are the two classifications, and why it's coming in the synchronous speed and other is the asynchronous. Okay, so here the main thing is that synchronous motors are working principle rotating magnetic field. Okay, so based on working is the rotating magnetic field. Here we can say this is the three phase motors mostly. Okay, not single phase. These synchronous motors mostly in the three phase, not single. Here the asynchronous motors, later we can see the three phase also there and single phase also there. Okay, so in asynchronous motors we having the slip ring induction motors and squirrel gauge induction motor. Okay, these are comes under the asynchronous. In case of the single phase induction motors, we can say that that's a bore well. So bore well has a motor here, that's capacitor start capacitor run motor, and capacitor fan is the best example for asynchronous mode. Okay, a table fan or a ceiling fan, whatever. So that's the one of the best examples for asynchronous. So synchronous speed, we can say that is a uh, this is a synchronous motor one. Okay, so which will use the power factor correction in the industries. Okay, as well as if it is motor, if we consider the in types of mission. Okay, if we without telling the motor, we can consider if it is a generator, then it is a alternate. Okay, that alternator we can say. Here we'll having the another classification, that is a single phase and three phase. Okay, so single phase and three phase motors. So here the based upon AC supply. So here in India we are using the 50 Hz AC supply. Okay, so 50 Hz AC supply, that is the 230 volts AC. Okay, frequency is the 50 Hz, 230 volts AC for single phase, and a three phase will depend upon we'll having the 440, and some cases we'll see the 410 to 440. Okay, so and the frequency also 50. So that is a depend upon the single phase motors, and another is the three phase. So in the three phase single phase also depending upon the working field, another classification also there. Okay, in the three phase we can say that we'll having the motors, that is a slip ring induction motor, SRIM, and another is the squirrel gauge induction motor. Okay, depending upon the that classification, we can say that uh, construction. Okay, so construction base, there's two types: slip ring and another is the squirrel gauge. So here is the, if you say that another classification, that's a constant speed, adjustable speed, and variable speed. Okay, so based upon this is the three classification: constant speed, adjustable speed, variable speed. So constant speed means with whatever the load we apply, then continuously run, that's constant speed. Adjustable speed means best example is we can say that by controlling. Okay, so by control we uh, if we by controlling the speed, if the motor runs it, that is up. So variable speed, so that is the limitation is there. So this motor will run this speed to this speed. Okay, as like we can say the tolerance value. Okay, next classification is the depending upon the structural features. That's the open type, closed type, and semi-closed type. So this is the based upon the constructional features we in terms of the rotor as well as state. Okay, so that is we can say that winding. Okay, so winding slots are there. So based upon the winding slots, how it will look like. Okay, so if it is this is the winding is slots is look like, it's a open type. Okay, so some case if it is a winding is slots is closed. Okay, this was a closed. Okay, so semi closed will also look like so. Okay, this is a open. Okay, so this is a three uh, types. Okay, so based upon the construction features, another is the, okay, so where we are using the location. Okay, submersible pumps and surface pumps. So mostly we are seeing as the surface pumps, and more other is a submersible which are using in the underground. Okay, so now talk about the synchronous motor. So the synchronous motor is a constant speed motor, and it can be operated the wide range of power factor. Okay, so this is the one of the best feature which you use the power factor correction for the industries. Okay, and why it is used for power factor correction, that will be know in the upcoming classes. And here is the double excited mission. Okay, so this is a double excited mission. Why it is called double excited mission, let me see. So another we can say that induction motor. Okay, so induction motor is a synchronous motors. There's a variable speed motors. Okay, and that will be work with the lagging. Okay, so these synchronous motors work with the only leading, lagging, and an okay unit power. But synchronous motor, that's in case we'll talk about the induction motors that will run at the different, okay, only lagging power factor only. Okay, not leading power factor.
Shall you notes PDF to me,
1 minute,
sir?
1 minute. Let's see. Okay, so let us see the induction motors, that is the asynchronous motors. So these are the variable speed motors and works with only the lagging power factor. Okay, so the synchronous motors which will work in the leading, lagging, and unity power factor. Okay, why it run the three power factors, that will now comes the based upon the upcoming classes. And here's some advanced. Okay, so here the, so these lectures are telling the based upon the to write the examination point of view. I giving the lectures because so SBTET conducting the two mid examination and one semester end examination. So in the point of view, I'm giving the lectures as a point of examination point. Okay. So here, so advantages of synchronous motor, that is the power factor can be controlled easily. Okay, so first we'll talk about the in the discussion we came that the power factor. Okay, so the power factor is here the mission is the double fed mission. Okay, so double fed means here we'll giving the stator as well as rotor. Okay, so here the motor. Okay, so let me consider the as we know as you know about the DC motor. Okay, so DC motor, so we'll having the rotor and the stator. Okay, so rotor will giving the supply, that is the DC supply will giving, as well as for stator also will giving the supply. Okay, so whatever the we supply given, that will be the stator and rotor. Okay, so that will be single supply only. Okay, so based upon the through the brushes it will be connected, that armature is connected, then the due to the magnetic field production, and here stationary magnetic field also produced in the stator as well as the rotor. Okay, due to the rotation, so here the motor will run. So similarly here what we are doing, so we are not giving the, so here what we are doing, so we are giving the here the double fed. Okay, so one is the, so one is for rotor, another is for the stator. Okay, so that's why here we are using the double fed. Okay, so that's why it's called as the double fed motors. Okay, so here we are giving the, that is for the rotor and stator. So here the rotor, for the rotor we are giving the DC supply. Okay, so for the rotor we are giving the DC supply, and the stator. Okay, so for the stator we are giving the three phase, we are giving the three phase AC supply. That's what's called the double fed mission. So rotor point of view we are giving the DC supply. Okay, and the stator we are giving the three phase AC. So that's will called double fed mission. And due to the excitation, so here what is the mean of excitation means, so here the rotor, whatever the rotor is there, so for the rotor to producing the magnetic field. Okay, so whatever the magnetic field produced in the rotor, okay, for the rotor, so we need this some amount of current. Okay, that current will given by the DC supply. That's DC supply is called as the excitation. Okay, that excitation we are controlled through a one potential divider. That potential divider, by varying the potential divider, the excitations will vary. Okay, that based on that the power factor correction is controlled. Okay, the motor, okay, which we whatever the power supply we are connected to the this RYB. Okay, that is suppose here we uh, run the machine for the in a laboratory. So whatever the laboratory we are let we consider, so here is a one lab is there. Okay, in the lab we are using the one three phase machine. So in the three phase mission, which are power supplies taken from the in this lab power supply. Okay, then whatever the supply we are giving, so the here, so due to the higher machinery laboratory equipment, so the total room, okay, the whatever the laboratory using, so total with the high machinery, the power factor is very low in that mission lab. Okay, suppose if we run, okay, in that stage, if we run this synchronous motor, so what will happen? So these motor, whatever the excitations, okay, if we control the excitation, so up to the rated value, okay, so up to the rated value, under value, and minimum value. So there three stages will be there. So that will be we can see in the there in the nameplate details. So in the nameplate details, it will retain the excitation. So up to the mark if we place, then it comes to the leading, lagging, and unity power. Okay. So based upon, so if we control the these excitation by means of the uh, potential divider for the rotor, then we can control. power factor for this laboratory. Okay, in this way, means by running the machinery in the laboratory, we can control the power factor. Okay, this is the one case. Next, motor can run at lagging, leading unity power factor. Okay, that is the by means of the excitation only. Because in case of if we talk about the DC motors, we'll only having the only DC supply one. We are not giving any double fed. So in case of induction, three-phase induction motor, so we are using only three-phase supply only. Okay, and rotor. Okay, rotor windings are closed. So that is act as a short circuited transformer. Like we can see. So if a single phase induction motor, that is another winding also there. So in case of the three-phase induction motor, that's the rotor is the short circuited one. This open is the stator. Okay, that's why the induction motors are called the short circuited transformer. Okay, secondary. Okay, rotating transformers we can say. Okay, we will giving the to the AC supply to the stator on the rotor. That's the mutual induction process. The rotor will rotate. So here speed is constant and independent of the load. Okay, so another main advantage is the speed. So the speed we can control. Okay, so through the excitation. Okay, so speed, whatever the speed is there, if it is to load, how much load we can apply, the speed also we can control. Okay, so that is how much load we can apply. The speed will be same throughout the whatever the load is, the full load conditions also. That's a major advantage of the this synchronous mode. And some disadvantage also there. So we talk about the it is not a self-starting motor. Okay, so we can say that all the three phase motor. Like if we talk about the so one thing major we can remember, that is asynchronous and synchronous. So here we are using that is slip ring induction motor and spiral gauge induction motors. These are not self-starting machines. Okay, so we need to use the one method. Okay, in one method we need to start the machine. Means um, so let's talk about the our ceiling fan. Okay, ceiling fan what will have we? So ceiling fan. So if we turn on the switch, it will be done. But in that we'll having the mechanism that rotating magnet will produce. Okay, so due to the two phase machine. Okay, that is single phase to two phase. That will conversions take places. That's why it's run at the at self start. Okay, so if we remove the capacitor for the ceiling fan, okay, that ceiling fan doesn't run. Okay, so similarly here in the why it's not self start. Okay, so we need to give the some mechanism, that is we need to give the any applications like, so we need to use the DOL starter. Okay, direct online start. Okay, that means we have to use the one starters. Okay, that is direct online starters mostly used. So here whatever the connection is means by taking the three wires to the directly to the stator, we cannot run. Okay, so we need to using the one proper starter is there. Okay, so that is the one thing we can see. Another is that it will require the DC excitation, because for the stator we are using the through the starter we are using the AC supply. For the in case of rotor we require the DC supply, because it will run at the double fed machine. Okay, so it will run a double excitation we can say. So here we we need double fed. Okay, that's why we need the one DC supply is another thing. For in case of SRM and SCM, so it doesn't require the DC excitation. Okay, and the initial cost is very high. Okay, because this is construction is similar to the generator. Okay, so whatever the construction is similar to the AC generator. Okay, that's why the cost is high, and it cannot be used for variable speed drive. Okay, so it cannot be used for variable speed. Means different variable speed we cannot use for the means here in the factories there are different drives up. Okay, so one thing we know that drive is different, motor is different. Okay, so drive is so only single drive machines or multi drive machines also. Okay, so if it is a motor is there, then motor whatever the rotor point of is there, if it's connected through the belt to drive, okay, through the belt. So if the 3 or 4 equipments are running, that's the single drive. Okay, so another 4 or 5 motors are running at the drive at a time, that is the multi drive machine. Okay, so this is the it cannot be used for variable speed drives. Okay, that's the main. And if the motor is overloaded, it may fall out of the step. Okay, that is a major thing. That is whatever the up to the load it can run. Okay, if it is too much load is run, then it fall from the synchronize. Okay, that's a major thing here we can observe. And it has a tendency to hunt. Okay, so hunting process also one of the major disadvantage in the synchronous mode. Okay, so we can know about these terms. So that is the hunting and other major terms are there that will be discussed in the induction motors. Okay, so let's talk about the applications. So applications of synchronous motor, it can be used for power factor correction and constants applications like clocks, air compressor, and centrifugal pumps. Okay, that's the small applications we can consider. And here improving the voltage regulations of long transmission line. Okay, these are the applications and frequency changes. Okay, that will be used in the frequency changes. So most of these are power electronic based applications and power sector. Okay, so here first before going to the working, so what the we'll talk about the so synchronous motors are the not self-starting motor. So that is a why it's not self-starting. So that we'll discuss in this lecture. Okay, that is the rotating magnetic field. So here rotating magnetic field. So that will be in detail. I explain the animation. That is better to understand. So here we can see the motor. Okay, so here the rotating magnetic field we can observe. So this is the one is the induction mode. Okay, so this is a synchronous motor. Okay, so here what we are doing, so whatever the stator part. Okay, so stator winding. Okay, that is if we consider having the winding having the three. Okay, so we'll have the three windings, that is R phase, Y phase, B phase, or A, B, C phase. So for each color the winding. Okay, so input and output. Okay, so these are connected at the one return. Okay, so each are placed at the 120 degrees phase shift. Okay, how it is phase 120 phase shift we can see here in the animation. So these are the 120 the phase shift the we can observe. So here the based upon the current flow. Okay, so as we know that thumb rule. Okay, so based upon thumb rule, whenever the current flows through that, the magnetic field will produce. Okay, so here we can observe that where the rotating magnetic field how it will be induced, because here we are using the AC supply. Okay, so to fed the machine for the stator part. Okay, not we are not talking about the rotor. Okay, first we're talking about the stator part. Okay, so here we can observe that here the we'll having the winding. Okay, so 6 windings we can consider the R phase, Y phase, B phase. Okay, so each one. Okay, so each are placed at the 120 degrees phase shift. Okay, so we can see that. So each one. So current flowing. Okay, current through the mission and current outcome. Okay, so we can observe. So we can indicating the plus is indicating that that is current is we can blowing through. Okay, dot point indicates that current is coming from that. Okay, so as we can see here, so that point. Okay, so this arrow point. So Based upon the arrow point, we can observe that plus indicates that current is flowing through. Okay, that indicates current is coming out. Okay, so we can observe the, so whenever due to the, we are using as a AC supply. Okay, AC means alternating power supply, right? So alternating power supply, what will do? Will having the positive and negative. Okay, and positive off cycle and negative off cycle. So due to the positive and negative off cycles, what will happen? The current is changeously from positive to negative. Okay. Similarly, due to the positive off cycle to negative off cycle, the current directions also change. Okay. So due to that, here we can observe. Here we can observe the, so here what will happen in each phase. Okay. So each phase current is induced. Okay. In each phase, whenever the current is flowing for each one, the magnetic field also changes one to other. Okay. So it will look like as a, we can say that, so the magnet is rotating. Okay. The magnetic field is, so it is a rotate. Okay, so there is that is one that is not rotating, so it will changes from one phase to the other phase, because due to the whatever the construction we have placed, there's 120-degree phase shift. Okay, that's why the waveforms also similar comes at the 120-degree phase shift. Okay, that is the main. So if you not place in the construction, that is mechanically, if not place the 120-degree phase shift, it doesn't comes to the 120 phase shift. Okay, so we are placing the windings as the 120-degree phase shift. Okay, that's will come as a 120-degree phase shift. Okay, so NAND is a 90 degrees. Okay, that's the main thing we can. That's 120, 121. Okay, that's 360 degrees. It is complete. Okay, so we can see here that is that it will due to the current direction. Okay, due to the current direction, the magnetic field is changing as a one to other. Okay, that is we can ask. Due to the alternation, the current also changes one winding to other winding, so it will be look like as a three phase. Okay, so it will look like it's a rotating magnetic field. So in case of four pole winding, so we can see the, this is the, okay, so this previously that I'll shows the, that's a two phase. Here this one is a four pole machinery. Okay, how it will be produced, because depend upon the windings construction, because so whatever the outcome will there, so based on it will be changes. Okay, so that is a number of files placed. So here we can see, so these are, so here here the windings are more, so is that is the number of poles are, so not like that, the outcome. Okay, so number of files based, so and poles, so how we are placing the poles inside one, that is the based on the rotating the poles also produced. So another we can see that uh, so we'll having another one. So here is the four pole machine. Okay, so this machine is a four pole one. How if this is in case of the DC machine, so what will happen? The positive and negative supply will gain. So due to the stationary, so that excitation, so will producing the only one direction only. Okay, so one direction flowing. That's we can the right hand thumb rule we can observe. Okay, so but in case of the this per we can say that for rotor point. Okay, but in case of the AC supply, that is when case the stator. Okay, for the stator, we will having the one is the these dot and plus symbols. Okay, the dot and plus symbol indicates that the current direction. Okay, so if dot symbol represents that, if your dot is current is coming outcome. Okay, so plus symbol indicates current is flowing through this. Okay, here we can see, so here u1, here current is flowing through here and current is coming from the, okay, that is we can here the how it will be changed. That is when positive to negative due to the current directions, the rotating field also changes. Here at a time, if you run at the three-phase supply, okay, so it will be look like as a rotating magnetic field. But actually, there is no rotation stick. Just magnetic field changes one phase to other phase. That's it. So here the we can see that when three-phase winding is displaced by 120 degrees, that is what we are doing. So for production of rotating magnetic field, so we are giving these windings at the 120 degrees phase shift. Okay, so whatever placing, so we are placing the at the 120 degrees. Okay, and they produce the resultant magnetic flux. Okay, so resultant magnetic. Okay, so we're not placing the individual. Okay, so whatever the three phases we are producing, that is the resultant magnetic field produced as a rotating magnet. Okay, and which rotated in the space as actual magnetic poles were being rotated mechanically. Okay, so which rotated in space if actual magnetic poles were being rotated mechanically. Okay, so this is a one thing generation. So here the principle we can say that three phase two pole stator having the three phase winding at 1 ton grid spaceship. Okay, so as we can see that we'll having the two pole mission and here one two. Okay, that's the DC supply we are using for the rotor. Okay, and here we'll having the this winding A B C. Okay, windings will have, so the poles we are whatever consider that's only we have using the two poles on. Okay, how it will be looking, that is we are placing the each places at 120 degrees phase shift. So for each one, for each phases we consider then magnetic field. Okay, so not we are considering the mechanical as well as winding place. Okay, so windings are placed at the 120 degrees apart from, okay, from each other. So whatever the windings are placed on 120, so that will be 120 degrees winding. Okay, so here this is the, if we can say that this is a. Okay, so if you place the at, okay, so let we consider, so this is the 90 degrees. Okay, so for this one, at this case this is the 120 degrees. Okay, and for this here, if you consider this one 90, and at this point we are changed. Okay, so another 120. Okay, for each phase we are placing the 120. Okay, for each one we are placing the another 120. So similarly we are getting the 6 one. Okay, that is another is the B B. So this one the C and the C. So these are how we are placing the this. Okay, so R is we can say the R Y B. Okay, so one is so how in terminal system. So here we can see the machinery connection. Okay, how it will be. There's a F1 F2. Okay, S1 S2 or this one. Okay, this is the supply we are giving how it. So here the flux is okay. So in this way, if you see that we cannot understand. Okay, that's show in the animation. So better understanding the how it will be producing the sinusoidal rotating magnetic field. Okay. So here whatever is the maximum. Okay. So this is the maximum flux will getting, and this is the how it will be, that is a positive to fluxes operating. Okay, so direction. Okay, so the mechanically, that is we are placing the poles, three poles in the 120 degree phase shift, so that's why getting the magnetic also 120 degree phase shift. Okay, so here derivation point of view, so how resultant flux. Okay, so 5 1 5 2 5 3 are these nothing but the three phases magnetic fields phases here. So let me consider the resultant magnetic 4 instant. Okay, so whatever the instant we talk about, so that is a 0 degrees, 90 degrees, 120 degrees. Okay, similar. So here, as we can see that here, this is let in case of the 0 degrees. Okay, how it will be look like. That is 5 maximum. How the mechanical placing. Okay, so this is the one corresponding that point 0. So this we can say. Okay, so one thing we can remember that, so whatever the in each cases this will be same. Resultant magnetic field will be 1.5 maximum. Okay, so that's one for 0 degrees, another for you can see. Okay, at 60 degrees, so next 120 degrees, another for 180 degrees. Okay, so that 4 instant, that is 0, 60, 120, 180. Okay, so resulting, so how it would be like this? See, in each cases. Okay, so it so is a 5 1, 5 2, 5 3. Okay, 3 corresponding points. So this representation, okay, how it will be changing. So here the 5 1, 5 2 are the, so max. Okay, is this vector of the equation, so it will be where. Okay, so the vector diagram representation we can see here. So in this a mathematical analysis, let we can at a time we can observe that. Okay, so here if you can see this the one of the thing. So this the one is the 0. Okay, another is the 60, another is the 120, another is the 180. Okay, so it is found that resultant matrix has a further rotated clockwise in an angle. Okay, so we can hear what here the rotating clockwise. Okay, rotating clockwise. So clockwise means yeah, like this. So in this direction, if we rotate means that's the rotating clockwise. So anti-clockwise direction means in this way. So opposite to the how clock is rotated. If rotations take place, this is the anti-clockwise. So here we are considering the clockwise direction. Okay. So if windings, let me see in the animation. Here. Okay, so here how it will, so at 0 degrees. Okay, so this is for at 0 degrees, how current is flowing. Okay, how current is flowing inside. Okay, so this is the 0 degree. So here we can see that this is the 0 degree at phase 1, and next is the how direction. Okay, how it is changed, that is the magnetic field is shifting from one to other. Okay, we can observe. So that is yeah, after closed one we can observe the, see for each flux. Okay, so each one, so there is a maximum flux system. Okay, at 1 degree, so here for this one, this is the maximum. Here for this phase, this is the maximum. Another phase, there is a maximum. Okay, so each phases, one is a maximum flux will producing. That is growing toward the whenever the phase is changing. So that is in case of the uh, different degrees. Okay. So in detail way, we can see in the next class. Okay, so rotating magnetic field. Okay, so because it will need the more interaction and more time for explaining the rotating mag field. So as well as my laptop also power is done. Okay, that's where we will goes to the next session. Okay.